Good morning, grade 8 students. Hope you are all doing fine. This is Miss Pamela Teeny giving the physics course. Today we are going to start chapter 4, section 2, electronic communication. So if you can all please open your books on page 114 so you can follow up with me. So in this section we are going to talk about several electronic devices and communication. Today we are going to begin with telephones. Telephones. A telephone is a device in which sound is transformed into an electronic signal that is transmitted and then transformed back into sound. So in a telephone, first you produce the sound. This sound is transformed into a signal in order to be transmitted. This signal is transmitted over a certain distance, and then when it reaches its destination, it is transformed back into sound. So let's say you are talking on the phone with your cousin in USA. First, you produce the sound. In the telephone, your sound changes into an electronic signal. This electronic signal is transmitted all the way to USA. When the phone of your cousin receives this electronic signal, her phone changes the electronic signal back into sound so she can listen to your voice. We have three main parts in a telephone. First is the transmitter. The transmitter is the part of the telephone that transforms sound into an electronic signal. So once you talk into your telephone, your sound is transformed into a signal inside the transmitter. The second part of the telephone is the receiver. The receiver uses a speaker to transform the electronic signal back into sound. It is located in the earpiece of the telephone, so it works opposite to the transmitter. It transforms the electronic signal to sound, not the sound into electronic signal. So once you receive the electronic signal from the other phone, the receiver changes it back into sound, and it is located in the earpiece so that you can hear this sound. The third main part of a telephone is the dialing mechanism. When you dial a telephone number, you are telling the telephone company's switching system where you want the call to go. This is why each one of us has a different telephone number. So if I want to call my home, I will dial a different telephone number than if I want to call my cousin, for example. Please, if you can pause the video for a minute and look at figure 6, page 115. Read and answer the question. So in figure 6, you can see a telephone and the three main parts of telephones that we already talked about. However, the answer is that the dialing mechanism sends a series of pulses, clicks, or tones to a switching network, telling the network where you want the call to go. If you want to read more about that, you can read beneath the paragraph with the title Telephones on your book. Now we are going to talk about electromagnetic waves. Why? Because electromagnetic waves have a very important part and role in electronic communication, and we will talk about that later on. But first of all, we are going to talk about what are electromagnetic waves. An electromagnetic wave is a wave that consists of moving or changing electric and magnetic fields. So this is why it is called electromagnetic. So it consists of both electric and magnetic fields that are moving or changing. Some examples of electromagnetic waves are light waves, microwaves, and X-rays. In the figure in front of you, you can see an electromagnetic wave. You can see that we have changing electric field and a changing magnetic field. The magnetic field is colored in blue and the electric field is colored in red. So the electric field goes up and down and the magnetic field is perpendicular to the electric field's motion. It goes right and left. There are two main characteristics of an electromagnetic wave. First, frequency. Second, amplitude. Frequency is the number of waves passing a given point each second and it's measured in hertz. So let's say 7 waves pass a given point each second, then the frequency is 7 hertz. 90 waves pass a given point each second, then the frequency is 90 hertz. However, amplitude is the height from the center line to the crest, which is the highest point in a wave, or trough, which is the lowest point in a wave. In the figure in front of you, first of all, we are going to look at the left part. In the left part, we have two waves. The upper one has a lower frequency. However, the lower one has a higher frequency. Why? Because in the upper one, a smaller amount of waves passes a given point each second. However, in the lower one, a greater amount of waves passes a given point each second. Now, if we look at the right part, we have also two waves. The upper one has a low amplitude and the lower one has a high amplitude. Why? Because in the upper one, the distance from the center line to the crest, which is the highest point in the wave, is smaller than in the lower one. Electromagnetic spectrum. The electromagnetic spectrum is the term used by scientists to describe the entire range of light that exists, from radio waves to gamma rays. Most of the light in the universe is, in fact, invisible to us. Light is a wave of alternating electric and magnetic fields, so electromagnetic waves are also called light waves. The electromagnetic spectrum shows the entire range of light that exists, from the smallest frequency to the biggest frequency. Now in the figure in front of you, you can see the electromagnetic spectrum, from the lowest wave to the highest wave. We have radio waves, microwaves, infrared waves, visible spectrum, ultraviolet, X-rays, and gamma rays. So if you look at the figure in front of you, you can see that the visible spectrum is a very small range inside the electromagnetic spectrum. So this range is the only range that we can see in our bare eyes. Other than that, we cannot see the waves. For example, radio waves and gamma rays, they are invisible to us. And each range has different uses. So how are electromagnetic waves used in electronic communication? Electromagnetic waves are used to carry electronic signals over long distances. So you can think about electromagnetic waves in our section as an airplane. And the electronic signal is the passenger. So the passenger gets onto the airplane, and the airplane carries the passenger over a long distance. So we use the electromagnetic waves in order to send the electronic signals over a long distance. Please, as a homework, solve numbers 1, A, B, C, and 2, parts A and B, page 122. This homework must be done by Thursday, 26 March. Next time we are going to talk about electronic devices and communication in more details. Thank you and good luck.